Okay, this is the video that's on section 8.8. It's talking about spheres. Now, a sphere is the set of all points in space that are equidistant from a given point. So when we talk about spheres, a sphere will have a center. It will have a radius, which is the distance from the center out to the edge. It will have what are called great circles, which would be the circle on the sphere that you get if you slice that sphere right through the center with a plane. And then if you slice it more than once, then you're going to get what are called lunes. And the easiest way I can describe a lune would be to think of it as the segments of an orange that all fit together to make a sphere that's the orange. If you take out one of those wedges, that would be what we would call a lune. Okay, theorem 8.18 says that the surface area of a sphere is 4 pi r squared. So 4 pi r squared. So if we look at this sphere and we're supposed to find the surface area if the radius is 3, then I just need to say S equals 4 times pi times r squared. So I get S equals 4 times pi times 9, which gives me 36 pi units squared. Now, a regular polyhedron is a polyhedron with faces bounded by congruent regular polygons and with the same number of faces intersecting each vertex. Now, there are only 5 regular polyhedra that are possible regular polyhedra, and they were discovered by Plato, so they're called the Platonic solids. And let me show you what those are. You have a tetrahedron, a cube, an octahedron, a dodecahedron, and an icosahedron. And what's important to note is that on each figure, all of the faces are the same size. So like on an icosahedron, they're all equilateral triangles. On a dodecahedron, they're all pentagons. On an octahedron and a tetrahedron, they're all triangles. And on a cube, they're all squares. So if you need to find the surface area of one of those, let's go back here. If you need to find the surface area, all you need to do is find the area of one of the faces, and then you can multiply by however many faces you have. So for example, if I'm trying to find the area, the surface area of an octahedron, I would find the area of the triangle, and I would take 8 times the area of the triangle to get the total surface area of an octahedron. So let's find the surface area of a sphere whose diameter is 16 meters. So I've got a sphere, and if the diameter is 16 meters, that means the radius would be half of that, which is 8. And since the surface area is 4 pi r squared, I'm going to want to take 4 times pi times 8 squared, and 8 squared is 64, so S equals 4 times pi times 64. So altogether I get S equals 256 pi meters squared. Next one is find the surface area of a sphere whose circumference is 60 pi units. Now we know that for the surface area, I need 4 pi r squared, but I don't have r. Instead, I'm told that the circumference is 60 pi units. Well, remember that circumference is 2 pi r, which means 2 times r must equal 60. So 2r has to equal 60, so r must be 30. So now I come over here and I need 4 times pi times 30 squared, which is 900. So I've got 4 times pi times 900. So my final answer is S equals 3600 pi units squared. And the last sample problem is, what is the surface area of a regular octahedron with edge 5 millimeters? Each face is an equilateral triangle. Well, we kind of talked about this before. If it's an octahedron, I have got 8 triangles. So the area of the triangle is going to be the square root of 3 over 4 times s squared, because they're equilateral triangles, and that's our formula. So I'm going to have the area equals radical 3 over 4 times 5 squared, because each edge is 5 millimeters. So when I multiply that, I'm going to get the area equals 25 radical 3 over 4. All right, now since I have 8 of those triangles, my surface area is going to equal 8 times that triangle, which is 25 radical 3 over 4. And then if you remember your fractions, I'll say 4 goes in here once and in here twice. So my final answer is going to be 50 radical 3 millimeters squared.